Today we're going to be taking a look at an A1707 Touch Bar MacBook that has already been worked on by a large national company. Upon inspection, we could see some previous rework to one of the CD3215 USB-C controllers. Otherwise, it looks pretty clean. I can't see anything too obvious right here. It's kind of hard to tell if this has been ultrasonic. You can't really tell a lot of the times, but this may have been ultrasonically cleaned. This near the CPU MOSFETs, it doesn't look like liquid to me. More just looks like flux left over from the factory. But otherwise, this does not look too bad on the front side of the board. So we're going to go ahead and measure DCIN voltage as always first. So if we plug in the charger, measure at the DCIN fuse, both sides, we get 5 volts. So there's something up with our CD3215 circuit, or USB-C circuit. I'm going to show you guys right now on this camera. So here's our multimeter, here's our fuse, and we get 5 volts. So we're going to take this board out and see if we can't solve it. So the board is out of the enclosure now, so we're going to go ahead and take a look and see if we see anything obviously wrong with it. So we notice these are two of our CD3215s. See how these look? The edges are not burned or anything. There's no sign of rework around them. And then we look at this side, and we see that this has been heated, and you see the other flux right here. Someone may think this is corrosion by it, but this is not. This is flux. It looks like kind of a nasty flux. But yeah, this is all flux, and this chip is clearly had rework by it. So, see this chiseling right here? This can happen in two ways. So this happens if you get the chip really hot, or if you're picking it up and gripping it, and while you're heating it off the board. That's a definite possibility. So let's look and see if we can see the balls under it and how they look. It might be a little bit difficult, but we're going to try and see. It's right by the edge of my bench. Move the scope forward a little bit. Now we should be able to see. So we can't really see under there. Could see under there a little bit, but not too great. We can't really tell what's happening under that chip. So in this case, we have two of them that have been reworked, and we know we have 5 volts on DCIN. So what we need to realize is, for one, we don't know what happened to this board. Since we're not the first ones that got it, we don't know what happened to it. We don't know if it had liquid damage, if it just stopped working. So the first thing we're going to check is PP3V3 G3 hot, which should show up around one of these USB-C controllers. So PP3V3, let's go G3 hot. And we're going to measure this. So C3100 right there. And let me grab a DCIN board, or a USB-C port, because I did not take one out. So we're going to take a USB-C port out of the enclosure here. Grab my T5. So another thing to think about is, if there's an issue with any CD3215 in the system, you will get 5 volts there. The CD3215s all need to communicate with each other and with the SMC to work. So an SMC issue is also possible. But without 3v3 G3 hot, which is basically very similar to what PP3v42 would do in the old boards, if that is not present, none of this will work. So let's plug it in and let's measure that. Now, the most common cause of PP3v3 G3 hot to be missing on the newer USB-C boards is a bad ISL9239. So we're going to plug this in. So inspecting the port a little bit. Doesn't look too bad. The port may be liquid damage, but I kind of doubt it. It looks like it's just worn, a little bit oxidized. Oxidation will happen with use. It's pretty normal. So we're going to plug it in. and measure. So one lead is on ground. Make sure we're set to volts, not diode mode. And that is 3.29 volts, so there's no issue there. So we have to think about this in a couple ways. So what could be going on? There could be several variables. If someone reballed these or replaced them, we have to think about why they replaced them. So were they corroded? Did it have 5 volts to begin with? And the second thing to think about is if they reballed it, did they reball it good? Has it been reballed poorly and that's why it's not working, or why is it not working? So you guys catch what I'm saying there. So we have to check a few things. I'm going to go around these chips, checking for shorts, so these little filters right here can blow too. So we're just going to go around checking for shorts, checking the basics here. That one's good. No signs of shorts around here. And I'm almost thinking, wait a second here. Is this resistor directly connected to ground? Should that be directly connected to ground? Let's have a look at the board view. I think that's okay if it's like that. Which resistor is that? It's going to be this one. What is the spec on this resistor? Let's have a look. I'm going to do a PDF search via Paul Daniel software, if it works. Which it's not working. So we're going to look at the PDF the old-fashioned way, and that is R3033. R3033. R3033 is the schematic says it's no stuff, which is strange because there's a resistor there. So the schematic is saying this is no stuff. And there's a resistor here with signs of previous rework. So if someone put that there without it's supposed to be there, it's going to basically create a short to ground. That's, you know, probably why it's well, I'm sure it has a purpose to begin with, but that should not be on there. So let's see if they even put the right one. We're going to measure resistance. Should be 100K, and we should have 100K resistance across this resistor. And we have 0 ohms resistance across that resistor. So we either have a short, or this resistor is really not supposed to be here. So we're going to put some flux down, remove this resistor, maybe give the CD3215 a little bit of a reflow too, because that flux looks pretty nasty. Go ahead and kick on the fume extractor. Let the board cool down a little bit. Let's see if we still have a short right here, because I don't think we should. I still don't think we should. But if there's a short on one side, that would... And no more short. So that's good. I think we just had... I think I would really be surprised if this worked. But simple mistakes happen, especially if you're replacing everything around around that area. Can't say I haven't done it myself. Plug it in. We still have 5 volts. Let's try a different port. Wonder if that's CD3215. So 0 volts now. Let's plug it in again. Sometimes the port will have junk on it and you won't get voltage at all. Try this one again. Or measuring the wrong fuse. Still 5.18 volts, so that wasn't it. Let's continue looking. That was a potential issue, but that may not have been it. I think what I'm going to do is pull these both off. Let's see, what's here? Normal. Because I noticed that was soldered upside down. Really doesn't matter though. Now this is interesting. We have 3 volts on one side and none on the other. So that resistor may be blown or it may be being pulled down, which may be 100% normal. So which one is that? That is going to be R3038, which is SMC USB-C INTL. So let me explain this a little bit. So I don't think my display capture is working, so I don't think I will be able to show that. So the SMC needs to talk to these with a signal called SMC INTL. That's going to be initialization signal. So most likely that signal is going to be used for the USB-C controller to talk to the SMC to initialize the whole circuit to work. So we're going to go back over and we're going to measure this resistor because I kind of think that's blown. With 3.3 volts on one side and none on the other, that seems either it's being pulled down by this chip or it's or that resistor is dead. So that resistor was R3038. We're going to look up the spec on that resistor. R3038. And that's a 10K resistor. That shouldn't, I don't think that'll pull it down like that. But let's see. Nope, 10K, that's normal. So at this point, we could have an issue with all of our, one of our CD3215s or all of them. Given the fact it looks like this, been reworked, I'm probably going to go ahead and pull these both off and put 2 new ones on. At least we could rule out those both as variables, because it does look like these both were replaced. However, we could still have an issue with one of these. Now remember that we need all of these to work. We need all of these to work before that's going to go to 20 volts. So even if one is dead, a completely different port will still read 20 volts. So I'm going to measure around here. That's low resistance. I don't know if that's supposed to be like that. This is definitely not supposed to be like that. So maybe we might have a short by one of these. Let's have a look. That's on the other side of the board. Flip my board view around. PP3B3 UPC TA LDO. That kind of sounds like it should not be shorted. Now I'm not 100% on that because it may be a low resistance line, so I'm going to go ahead and measure, and I may even grab another computer with the same board or a similar board and measure that signal to see if it is low resistance. Or what we can do is just inject a little voltage into it and see if anything gets hot. since there is a few caps on this line, and then this does look like it comes from UB090. So we're going to look up UB090. UB090. And that chip is actually powered by... Now, okay, so if we look at this chip, we see a lot of Thunderbolt signals coming out of it. So, if we notice before, we had low resistance on this chip right here. So, I mean on this capacitor right here. Which so happens to be a USB Thunderbolt signal. Now, if this chip right here, or if this rail right here from this cap is being used to power our circuit, we might have a short in one of these chips. So what we're going to do is go ahead and just debating either injecting voltage or just pulling both of them off. I guess I could just inject voltage and see what gets hot. Because, yeah, 3.3 volt line should not be that low, especially if it's used as a VCC chip. So let me make sure I want a good place to inject voltage here. So this, it could be any one of these caps on this rail. It could be this chip, could be this cap, could be this cap. So let's go ahead and inject a little bit of voltage here. We're going to inject about a volt. Actually, yeah, 1.5 volts should be plenty. Some flux down. I'll do it on this one. Why not? Sometimes you will put your power onto the component that is shorted, and then it won't work. Well, what will happen is, so normally when you inject voltage on a board, the point that you're injecting voltage into will get hot. So sometimes you confuse yourself if you inject voltage into the shorted component directly. So I'm going to go ahead and put a little bit of solder on. No good way to get it in there because it's so close, so we'll go ahead and use this one. That one's too close to the chip. This one's kind of the same thing. Here we go. Ground lead. My ground lead came unhooked, that's why I wasn't pulling any amperage. So we're only pulling 0.45 amps, and that does not, usually if we have a short, we will get way more than that. So so it's either a partial short or it's normal like that. So let's go ahead and measure voltage while injecting power and see how much it's pulling it down. And we have 1.48 volts there. So I really don't think we have a short there. I'm pretty sure that's normal. Yeah, pulling 1/10 of an amp, we have no short here. So that must be a low resistance line that I just got tricked by. So in this case, I guess I'll go ahead and replace these two CD3215s that were messed with prior, or take them off at least and have a look, starting with this one. So there's a good chance that someone screwed up the reball on it. Or you don't know what they did, they could have just reballed a bad chip, so let's go ahead and pull this one off. And there's hardly any solder on those. There's like no balls. See what I mean? Look at that, no balls. No wonder. Wonder if I reball this old one, if it'll just work. Because that does not look like enough solder on those. So just for fun, I'm going to reball these, because you can see that there's hardly any solder on those. You guys have seen how when I take off SMCs, there's plenty on there. There really isn't much here. So what my guess is it was replaced and it wasn't reballed. It was just solder put on it and then tried to reball. I mean, if you're a tech, you've probably tried to do that before. At least I have when I was starting. Is just put solder on the both pads and hope it flows into place. But that's really not a way to do it. So we just cleaned up that old solder on there. I'm gonna clean it up. Grab our CD3215 stencil, and hopefully we will have a healthy board. We're gonna do both of them. But now we have to wonder, was the CD3215 the original issue? Or was it just blamed as a CD3215 issue? Need a paper towel and a stencil. Small stencil. Extremely small stencil. So our chip is nice and clean. So go ahead and position the stencil, line it up. Just like that. Wait a second here. I'm backwards. Nice and lined up. We're going to grab our smallest Captain tape that we have, because that's the only thing that's going to fit on the edges. I don't really clamp them down, I just use Captain tape. It's cheap, simple, and I've never had a problem with it, so I've never really thought of buying a clamp because I use what works, and this works just fine. So you're going to lose alignment when you put on the Captain tape. Happens every time. What I kind of do is put the Captain tape on there and then and then align it. So I'll get 2 strips on here, and then I'll place it back down and then tape it more. So we don't want it to lift when we're heating it either. It usually won't, but the 2 strips are just going to be to position it, and this is a real pain. Hardest part about it is getting your Captain tape on the stencil, especially with how small this stencil is. So now we have 2 pieces on here. I'm going to align it. Dropped into place real nice. I'm going to hold it, take this piece off, move it over a little bit, or at least attempt to, because now it's stuck to the tweezers. Yeah, reballing is a real pain, honestly. I really dislike reballing stuff. Now there's probably people that fix iPhones that are laughing at me as they watch this, but that's okay. Grab another strip because that one got destroyed. The thing is, we don't want the Captain tape covering where our balls are going to go. And that's what's kind of tricky about it. Now I can go ahead and tape the other directions. I'll include timestamps in this so you guys don't watch a overly long video that's boring. With long videos, especially with my channel, people have 2 opinions. Either they don't like them or they like the process. So could never win with YouTube, honestly. People tell me my audio is too quiet, so I raise the volume. Then people say it's too loud, so I lower the volume. Then people say it's too quiet again. So YouTube is one of those things where no matter what you do, there's always going to be someone complaining about something. And that's part of it. If you make videos, you have to deal with it. I have a feeling with my channel, if I got the most expensive microphone in the world, the most expensive camera, people are still going to complain just to complain. Another piece on top. Notice how the chip is moving underneath. That should stop. We're going to put one more at the bottom and then another one on the other side to stop it from moving. And while I place this, I'm going to place it on the stencil but not on the mat yet. I'm going to move it in place and then tape it down. And now that should be solid. The final piece is going to go on this side. At least this place did not rework it to the point of destroying it like some places do. So I will give them that. So now we're going to grab our solder paste. Put a little bit down there. When you have a stencil, these aren't bad to reball at all. Of course, I say that, and now it's probably going to get screwed up. I've learned not to talk about stuff like that. You never say that something is working fine or that something works good, because the moment you say that, it's not going to work. Something always breaks after you say that. Another thing is if something is in your way and you want to get rid of it, never get rid of it, because a week after you get rid of it, you're going to need it. So we're going to go about 315 on the heat and about 10 on the airflow. Start from far away. Most solder pastes will melt at a temperature like that. Might go a little bit hotter. I'm going to switch to my big nozzle actually, because that'll preheat the whole stencil and not just a small area. We have some nice balls formed. Good to go to pull out. I'm going to let that cool for a second until the balls dry. Because if you pull it off with the solder paste, still melted, it's obviously going to make a mess, and it will take a few seconds to dry. See, now it's dried, so we can go ahead and take the stencil out. Now, to take the chip out, don't use the same temperature. What I used to do is just blast them, especially SMCs, with full airflow, but you'd risk messing it up. So what you do is 100 Celsius at max air, which is obviously not enough to melt the solder, and if it is enough to melt the solder, you are using the wrong kind of solder paste. Just heat it. Just gently pull it out. Look at that. Nice first attempt CD3215 reball. Not a retry, nothing. Just perfect. Now see how there's actual balls here? See how there's actual balls when before there really wasn't? This is how it should be. That's how it should look. There just wasn't enough on the board or the other chip for that to work, I don't think. So we're going to go ahead and put this on the board now. Try it. We might have to do the other one. We probably will have to do the other one if it looks like this. And hopefully it'll work. So here's our board. We're going to go ahead and wick away this excess solder here. You can see again, there's just nothing there. I don't think there was balls there. Should be good. So it looks like they use lead free, because leaded usually won't do that like that. So we're gonna add a little bit of leaded here where the other pads were. Doesn't matter how much, because it's just to get rid of the leaded, so we don't lead free, so we don't mix it. Now we should be able to wick it nicely. And this pad can go right back here. No, not a big deal. And that is good. We're going to go ahead and clean. And move this guy over just a little bit more. That's good. I'm going to go ahead and put down some Amtech VS213-A flux, which is, I like it better for placing reballed chips. It just seems to work a little bit better, and it seems to flow them into place a little bit better than 559. And our chip. I'm expecting it to still be 5 volts because the other one was reballed too. I'm going to go 430 at 30 liters per minute. I'm going to start from far away. Now it's in place. Could turn it up a little bit more like max air. That is good. Go ahead and let it cool a little bit. And as it's cooling, I'm going to plug in my USB-C port. Should be cool enough. And plug it in. $5 volts still. It's expected, like I said. Wait a second. No, we get 20 volts now. What's that? 20 volts. Let's have a look at this. $20 volts. We're good. So, this was just badly reballed. That was it. It didn't have balls on it. And I'm going to go ahead and do the other one too, because that's probably going to be the same. Same place, same chip, same thing. have the board back in the enclosure, I'm going to go ahead and hit the power button. It's been plugged in for a little bit because these will not boot if the battery is dead. So power button. These will take a minute to post too, so I have to give it a minute. Just going to lean it like this. Fan is spinning. Apple logo. And this is fixed. So yeah, so the issue was CD3215s had signs of previous rework. There was a resistor placed where a no stuff resistor should go, which is basically no resistor. It's not basically, it is where no resistor should go. So we were basically connecting a signal to ground when we shouldn't have been. One of the CD3215s was not reballed properly. It really had no balls on it or not enough solder on it, and that was the main issue causing this not to work. So this is good to go, and thank you for watching.